Okay, so I'll go to question number 1 here. That's question number 1 there. They're saying define the following terms. Okay, so in as much as you are solving questions in math, when you're doing math at 1001, it's expected of you to know the definitions, right? Especially those first things that you did about sets, binary operations, functions, relations. You have to know those definitions because they will definitely come in the exam. They'll pop up, definitely, okay? So make sure you go through those notes that you were given by the university, okay? You just water those to my definition, so that in case they pop up, you can be able to define them, right? Okay, so the first one there, they're saying define an infinite set, okay? So what is an infinite set? An infinite set is simply a set that contains elements that you cannot count. Like it has a lot of elements such that those elements are uncountable, okay? That's what an infinite set is. A set that contains an uncountable number of elements, okay? It goes on forever. That's an infinite set, okay? And then here they're saying define an identity element, okay? So what is an identity element in simpler terms? An identity element is just an element such that when you apply an operation on it with another element, you still get the same element, right? Okay, so let's say, for example, I have, okay, let's say, for example, I have F here as my element. And then on this F, if, for example, I apply this operation, a star, with an identity element like that, okay, what I should get here should just be the same F, okay? So if you apply a certain operation on an element there, then you get that same element. The element that you are applying there becomes the identity element, okay? So this will be equals to the identity applying the same operation on F, and then this will be just be equals to F, okay? So if you have an element like this one here, that has a property where if you apply it, you are getting the same thing that you started with, then we call that as an identity element, okay? So you can even switch the English as long as you just bring out the point. That's it. Whatever you start with is what you're going to end with when you apply that element, right? Okay, so that's an identity element. And then, okay, let me give an example here in case someone has not understood. Okay, let's take the operation addition, okay? Let's take the operation addition. What's the identity element for addition? The identity element for addition is just 0, okay? Because I know that 5 plus 0 is equals to 0 plus 5, and this will be equals to what? To 5, right? Okay, so this 0 here is playing a role of an identity element because when I apply this addition operation with the 0, it's giving me back what I started with, okay? And then let's look at multiplication. Multiplication, let's say I have 3 multiplied by 1 is equals to 1 multiplied by 3, okay? You see I'll get 3. So this one here is an identity element under multiplication. Then under addition is just the 0, right? Okay, I hope that is clear now. Then how do you define a bijective function? Okay, how do you define a bijective function? Okay, so bijectivity, it simply means that, okay, every element of the set A has one and only one image in the set B. Okay, so for example, if I have my set A here, okay, and then in this set A, let's say it's that I have 1 and 2. And then on the other side, I have B, and then in that B, I have maybe 3 and 4, okay? So what does a bijective function do? Okay, a bijective function is simply a mapping from A to B, where each element of A is associated only with one element of B. So it will be something like that, okay? So this is a bijective function because one element of A is being mapped to one element of B, okay? In short, each input function here has a unique output function there, okay? That makes it a bijective function. Okay. So as long as you stress out that point in your explanation, you can put it in whatever ways you want. Okay. So now let's go to B. I hope you've understood. Okay. So now we'll go to B. So B says what? Okay. Okay, so they're saying for each of the following binary operations, okay? By binary operation, they mean it can be the star symbol, okay? It can be a circle with a plus. It can be any symbol. It can be an A, a minus, if they the bar on top. It can be a plus. It can be a multiplication. It can be a minus. No. Minus is not a binary operation. Okay, so just those 5 there. Okay, so we are saying for each of the following binary operation, find an identity element. Okay, for each of the following, which means 1 there and 2, find an identity element. Okay, so the first one, they're saying define star by A star B is equals to A plus B minus A multiplied by B. Okay, so this is what we have on number 1 there. We have A star B, okay, is equals to A plus B minus A multiplied by B, like that. Is it correct? Okay, yes, it's correct. Okay, so this is the situation that we have on B1 there. Then they're saying find an identity element of this, right? Okay, so by definition, we know that whenever you apply an operation with an identity element, it has to give you the same element that you started with, okay? So you say let A star, okay. Before I write that, okay. So you say let E, here you can use any letter if you want, okay? So let E be an identity element, okay? An identity, I'll just write in abbreviations here, okay? So let E be an identity element, okay? So what will that mean when I apply this B on that A, okay? So it will mean that A star, this E, okay, is equals to E star A, and this will just be what? A. Why? Because we're taking this E as an identity element, right? Okay, so now we are going to apply this operation here that we've come up with, this one here. We are going to apply it on our given question there, okay? So wherever there's B there, which is the second element, we are going to replace it with the E there, okay? And then solve for E. That's simply what we are doing. So we are going to say A star E is equals to, okay? Remember, we are using that equation there. Let me even use blue. Okay, so we are using that equation there too, right? Wherever there's B, we are putting E. So it's going to be A plus E minus A multiplied by what? E, like that, okay? But we know that A star E here is equals to what? Is equals to A, right? Okay, so here where there's A star B, we're going just to put A is equals to, okay, and then A plus B, we'll leave it like that, then plus E minus AE there. Okay, so what do we get from there? Okay, what do we get from there? We put the E's together and the A's together. So how are we going to have here? We're going to have a situation where we have A minus A is equals to E minus AE, like that, right? Okay, and then we know that this here is going to give us what? 0, right? Okay, this is A minus A. So this will be 0 is equals to whatever we have there. But let's write whatever we have on our right-hand side, we write it on the left. So E minus AE, okay, is equals to 0. Where is this 0 coming from? A minus A is 0, right? Okay, and then from here now, we can factorize our identity elements. This is what we want to find. So when you factorize the E here, you remain with 1 minus A is equals to 0. And then we solve for the E now. Okay, so E is going to be equals to 0 divided by 1 minus A. And we know that 0 divided by anything there, okay, it's just 0. Okay, so our E is 0. So it means our identity element in that question was just 0. Okay, so what do you have to do in order for you to find the identity element? Let me run it through. You assume, okay, you assume that let E be an identity element, okay? And then after that, you multiply it, you apply the operation that you've been given, okay? So A star E, if this E is an identity element, should be able to give you E star A, and this will just mean that that is equals to A, right? Okay, and then now you come back to what you've been given there. Wherever you are seeing the B there, the second element there, you're going to replace it with A, with E, I mean, okay? So this is what we did here. We replaced, and then you solve for E, you find your E as 0 here. So our identity element in that case is 0. So that's how you find it. Okay, maybe let's try to do number 2. Okay, so here, number 2 here, they're saying what? Find the identity element for a binary operation on A, okay? So it means this A with a bar on top here, that's the symbol for their binary operation, is defined by P, A bar Q is equals to P plus Q plus the cube root of 15, okay? So let's do that. Okay, so number 2 now, what do we have? Number 2, we have P, A with a bar on top, and then Q is equals to P plus Q plus the cube root of what? 15. So these things are very easy, guys. These are free marks if they come in the exam, okay? Because they are just proofs. Okay, so our first assumption is always to let what? To let E or any letter of your choice be an identity element. So you are going to say let E, okay, be an identity element, right? So you write in full here, I'm just writing in abbreviations. So it means when I apply this operation here, because this A with a bar on top is an operation, it's not an actual A. So it means when I apply P and then this operation to the E, I should be able to get P, right? So I'm going to say P, okay, with this operation with the E is just equals to E, the same operation there, P should give me what? P, okay? This is just a definition of what an identity element is. Okay, then from there, okay, from there, we are going to replace wherever there's Q here, the second element, we are now going to be replacing by E, and then solve for that E. So we are going to say now P, A, bar on top, where there's Q, you put E, is equals to P plus, where there's Q, you put E plus the root of 15, the cube root of 15. Okay, but we know that P, okay, we know that this guy here, we can see here is just equals to P, right? Okay, so here I'm going to replace it with P is equals to P plus E plus the cube root of 15. Okay, so this is what we have now. So we can take the P on the other side. So you can see that when we take the P to the other side, it will just be P minus P, which is 0, right? So here we have 0 is equals to E plus the cube root of 15. Okay, and then from here now we want to solve for the E. So meaning we just take this cube root of 15 to the other side. So it means our E will be equals to what? Minus the cube root. Why am I writing E there? Okay, to be equals to minus the cube root of what? 15. So in that number 2, okay, this will be our identity element. Okay, so that's how you do that. And then we go to other questions.
Sorry, sir, I have a question.
Yes, you can ask.
Why are we saying E is equal to a negative cube root 3? Like, where is the negative coming from?
Okay, so you've seen here the equation that we have on top there, where we have 0 is equals to E plus the cube root of 15, right? Okay,
Yeah.
so what I've done, I've just gotten this guy here, the cube root of 15, this guy here, which is positive here. I'm taking it to the other side. So meaning it will change sign, right?
Oh, okay, I see.
You've seen
I
where
see.
it is coming from?
Yes, thank you.
Okay. All right. Here. Let's go to this. C. Okay, so what is C saying? C, they're saying show that, okay? They're saying show that the cardinality of a power set A with one element is 4 and list its element. Okay, so here we are trying to prove that a power set of a power set with one element, okay? The cardinality, we all know what cardinality means, right? Cardinality means the number of elements in that set, okay? So this question is simply telling you that prove that number of elements in the power set of the power set of set A, okay, with one element is just 4, and then list all the elements. That's what they are saying here. Okay, so let's do that. Okay, so we are going to say let our set A be, let A be equals to, okay, they've said A has only one element, so we can choose any element we want, okay? So my set A can be that one, right? Okay, so this is my set A, and then let me find the power set of this. And we know that the power set is just listing all the subsets of that set A. Okay, so the power set of set A will be equals to what? We know that this set here, how many subsets will it have? It will only have 2, an empty set and itself, okay? So if I list down the power set of A, it will just be the set itself, okay, comma, the empty set. Because say the empty set is a subset of any set, right? Okay, so this is the power set of A. So the power set of A has how many elements? 2. But in the question, they said the power set of the power set of set A. So meaning we have to find the power set of this power set. I don't know if I'm making sense, okay? So this is A, this is the power set of A, and now we want to find the power set of the power set of A, right? Okay, so we are finding the power set of the power set of A. This is what we are finding. So this is going to be equals to, okay? So this the subset of this set here are going to be what? Okay, you can get the one there, okay, then you can get the empty set, okay, and then you can get the set itself together like the way it is there, okay, and then you can get another empty set. Okay, so this here is our power set of the power set of A, okay. List first the sets that are there, get the set itself, and add an empty set, right? Okay, so this is what we have there as our element. Then now we have to find the the cardinality of this, right? So meaning the number of elements in this power set of the power set of A. So we're just going to say n, meaning the number of elements in this power set of the power set of A is what? Okay, you just simply count. So you have 1, 2, 3, 4. Okay, this is counted as 1 here. This guy here counted as 1 because it's here as a whole set. Okay, so we can see that the cardinality there is just equals to 1. Is just equals to 4. So we have shown here, and this is the list, and then this is the 4 there. Okay, I don't know if it makes sense, but that's how you do it. Okay. Let's go now to the other question. Okay, so D now, that's what we are solving there. They're saying what? Suppose, okay. Okay, they're saying suppose a group of 70 patients are surveyed and asked which disease they have suffered the most. There are 3 diseases in our surveys, okay? Malaria, cholera, and 1 for asthma. And then they're saying 40 patients suffered from malaria, 20 suffered from cholera. And then they're saying 9 patients suffered from asthma, 11 patients suffered from malaria and asthma, 9 patients suffered from cholera and asthma, 15 patients suffered from malaria and cholera, and then 5 patients suffered from all the 3 diseases, okay? And then the questions come now, okay? So before you answer any questions on this type of a question, you first have to represent, okay? You have to represent your data on a Venn diagram. Then once you represent it on a Venn diagram, it's going to be very simple for you to answer these follow-up questions here that they have, okay? So let's represent this on a Venn diagram. Okay, so I'm going to write my Venn diagram there. Then I'm going to put 3 sets here, 1 for malaria, okay? The other one for cholera, and then the other one for asthma, like that. Okay, so I'm going to label this malaria, cholera, asthma. And then we know that the whole box there is just the universal, right? Okay, so for such questions, you always start where you have the intersection of all the 3 diseases. So here they're saying 5 patients suffered from all the 3 diseases, right? Okay. So it means here where all these elements are intersecting, I'm going to put 5, okay? I'm going to put 5 there. These 5 suffered from all the 3 diseases, right? Okay, then from the intersection of all the 3 sets, I'm now going to the intersections of two sets. I'm going to go for malaria and cholera, cholera and asthma and cholera. Okay, so if we go on the question, how many students suffered from this malaria and this cholera? Okay, so here we can see that 15 patients, okay, 15 patients suffered from malaria and cholera. So when I come here, I know that in the malaria and cholera, I've already put 5, right? Okay, I've already put 5. So from that 15, I'm going to subtract 5, and then I'm going to put what is remaining here, which is the 10. Okay, you can see that this makes 15 suffered from malaria and cholera, right? Okay, then I go to the intersection of cholera and asthma, and the asthma there. I'm going to do the same. So in the question, they said 9 patients suffered from cholera and asthma. So I've already put 5 there, meaning here I'm just remaining with 4. And then in the question, they said 11 suffered from malaria and asthma. So I've already put 5 there, meaning I'm only remaining with 6 there, right? Okay, so this is how you fill this Venn diagram. Then from there, now I can go to my individual sets, okay? So for malaria, they said, how many did we have there on the question? So that they said 40 patients suffered from malaria, okay? 40 patients suffered from malaria, but we already have these numbers here. So this is 5 plus 6, which is 11 plus 10, which is 21, okay? So you subtract 40 minus 21. Whatever is remaining here is the number that you put there, which is 19, okay? And then we know that how many suffered from the cholera, okay? We know that we have 20 people suffering from cholera. And here in the cholera here, I already have 10 plus 5 plus 4, which is 19. So how many is remaining? Only one. You put 1 there. And then how many suffered from the asthma? Okay, I've forgotten the number. So asthma, 9 patients suffered from asthma. So is that correct? No. Let me check again. Okay, so 40
It's 30
patients.
patients.
Okay, 30, right?
Mm.
Okay, so I'm going to use 30 there on the asthma. Because this 9 won't make sense. Okay, so 30. So let's add whatever we have there. We see we have 6 plus this, which is 10 plus this 15. So 30, okay, minus 15, you're going to get 15 here. Okay, and then once you are done, you add all these numbers and see if they add up to that 70 that they said, okay? If it doesn't add up, it means that there were some people that had no diseases at all. Okay, so if you add all these, what do you get? This plus that 20, I have a 20 there. Okay, so this is the 20 here. No, 10 there, 20. Okay, then 20, 40.
I have a question. Why
Okay,
are
so
we saying, why, like for asthma, you added 10 and 15
I
for
added what?
asthma? Like for the asthma patients, is it not supposed to be, are you not supposed to be adding 6 and 5 and 4? Oh, that gives us 15. Okay, never
Yes,
mind.
it gives
Got
us
it.
15. Okay, so when you
Okay.
add all these numbers in these circles, you are getting a schist, okay? But remember that the total survey of the 70 people, right? Okay, so meaning 70 minus 60, you have 10 people that had none of these diseases, right? Okay, so that will be our Venn diagram there. And then once you draw a Venn diagram, it means the rest of the question will just be seen. You'll just be getting your answers from the Venn diagram. Okay. So for example, they're saying how many patients do not suffer from any of these diseases. Okay. So from the Venn diagram here, we can see that 10 didn't suffer from any of these diseases, right? Okay. And then 2, what are they asking us to do? They're saying how many people suffered from cholera and malaria, but not asthma. Okay. So cholera and malaria, but not asthma. It means we're getting all these people here. You can see these people, right? Hello?
Hello.
Okay, so they're saying
Yes.
cholera. How many suffered from cholera and? Did they say and or? Okay, so how many suffered from cholera and? So meaning cholera, which is C intersection M. Okay, so we are finding these people here. Cholera and malaria, but not asthma. So what are we going to get here? So cholera and malaria, but not asthma, are these people here, which is just 10, right? Okay, cholera and malaria, but not asthma, just be 10 people again. This got 10 here. Okay, and then, yeah, dang, my slide is gone. Okay, let me try to get it back. Where is it? Okay. Oof. Still not visible, I think so. Let me close this one. Then I open it again. Okay, yeah, I think it's visible now. Okay, so we are on which one? Oh, we are done from there. Okay, that's good. I thought there were more questions on here. Okay, so we are done with question D there. We found there, we just found 10, even there we found 10, right? Okay, so let's move on to, I think it's question 2 now. No, we have E there. Okay, so let's solve E, and then E, they're saying what? They're saying let f be a function defined as f of x is equals to 3 plus 1 for x is less than or equal to -2, and then x squared minus 1 for x is greater than -2, but less than or equal to 2, and then 1 minus 2 x for x is greater than 2. Okay, so what we have here, guys, is what we call as a piecewise function. Okay, a piecewise function, a PWF, piecewise function. This is what we have there. Okay, so here on number 1, they're saying show that f of -4 is the same as f of -6. So those input values that you decide to put on this x, okay, they will depend on the ranges that you have there. Okay, so if they give you a number, for you to decide which of these 3 equations to use here, you have to consider in which region it is. So for there, they're saying f of -4, f of -4. So f of -4 is in which region here? Okay, f of -4 is in which region here? We see that it's in the region x is less than or equal to -2. That's why you find your -4. Okay, so it means when replacing this -4, we are going to use this equation here. Okay, and then f of 6 there is in which region? You can see it's in this equation, the last equation, where x is greater than 2. Okay, so meaning we are going to replace 6 in that equation here. Okay, I think so. Let me do it right here on this page so that you can be seeing the piecewise function and the values we are replacing. Okay, so meaning let's find f of -4. Okay, so f of -4 is equals to, someone has a question?
Yes.
Yeah. I do what?
Can you repeat the explanation of how to know what you're supposed to use?
Okay, so I was saying that, okay, this is a piecewise function, okay, where a certain equation is only valid in a certain region, right? Okay, so we can see that the x plus 1 there is only valid when this x is less than or equal to -2. And then this x squared minus 1 is only valid when x is greater than -2, but less than or equal to 2. And then this 1 minus 2x is only valid when the x is greater than 2, right? Okay, now coming to this question, the first one, they're saying find and show that f of -4 is equals to f of 6, okay? So it means we are going to be replacing these -4 and 6 into one of these equations here. But how do you know which equation to use? So you just follow the value that you've been given here. So -4 is in which of these regions? Okay, we see that you only find -4 after in this region here, which says x is less than or equal to -2. Okay, if I draw this region on the number line, if this is my number line, then I have -2 there. Okay, that region there represented by the first interval there, it will be starting from here going all the way to infinity, right? So meaning our -3 there, -4. So you can see that where we find our -4, it is in that region here. So meaning for finding f of -4, we are going to use this equation here. And then for the 6, we do the same. We look for an interval where the 6 is. So the 6, you can see that it will be in that last region there, where the x is greater than -2, okay? Because the x is greater than -2, it means 3, 4, 5, 6, just like that, right? So this is where we're going to find the 6. So for finding f of 6, we're going to use this equation. For finding f of minus 4, we are going to use that equation. Okay, so f of minus 4, we're just simply using 3. Then where there's x there, I put minus 4. Okay, and then I say plus 1. So what am I going to get here? This will be 3 minus multiplied by minus 4, which is minus 12. And then plus 1, which will just be what? Minus 11, right? Okay, and then f of 6 is equals to, what equation are we going to use? This last one here. So it will be 1 minus 2. Then I have a 6 there is equals to, this will be 1 minus 12, which is also what? Minus 11, right? Okay, so we've shown that what? F of minus 4 is equal to f of 6, because here we're finding the same answers there. Okay, so you can write a statement after showing this. You just say, therefore, f of, what's happening to my pens? So f of minus 4 is definitely equal to what? F of 6 there. Okay, you can write as shown there. Then you'll be done. Okay, so now where the bit work is where you are graphing there. Okay, so they are saying sketch the graph of f of x. So this is a piecewise function, meaning we are going to sketch it in steps or in stages. Okay, we're going to sketch it in steps. So it means that we're first going to sketch the first graph there in that region, and then sketch this graph in this region, sketch that graph in that region. Okay, so let me go to a new page here, then write my piecewise function here. Okay, so my piecewise function is f of x is equals to, okay, f of x is equals to, what do we have there? We have 3x plus 1 for the region x is less than or equal to minus 2. And then we have x squared minus 1. Which region? We said minus, is that minus 2? Let me check. Okay, minus 2 greater than, so minus 2. Then we have x, this time we're equal to 2. And then the last one, we had 1 minus 2x. For what region? Here we had x is greater than 2. Okay, x is greater than 2. So this is what we have. So to graph it, we're going to graph first this guy here in this region. Okay, so if I draw my my graph here, let me use black. Okay, so we are going to sketch it step by step. So if I have my XY plane here, okay, XY plane there. Okay, so these are my Y values, and then this is my X. Okay, so you're going to have your 0 there. And then can have a 1 there, and then a 2, 3 there. Then this side you can have minus 1, a minus 2, then minus 3. Okay, and then going down, minus 1, minus 2, then minus 3 like that. Then up, we do the same 1, 2, 3. Okay, so we've drawn our XY plane. What is remaining now is to put the graphs there. So we're going to start with this graph here. Okay, so if I get that graph and draw a table of values for it, what am I going to get? Okay, so table of values. So this is my x there, and then this is my 3x plus 1 represented by y. Okay, and then I try to put in values there. Let me say I put in minus 2 there, minus 1. What's happening to this pen? So, okay, so I put minus 1 there, and then I put 0 there. Okay, so I can end there. So if I put minus 2 there, what am I going to get as my corresponding y values? You can see that 3 multiplied by minus 2 to be minus 6, right? And then plus 1, that would be minus 5. And then if I put minus 1 there, means here I have minus 2. And then if I put 0 there, it means here I have 1. Okay, so you can see that this graph, if I put this minus 2 here, I'm going to get a minus 5, which will be somewhere below the negative 3 here. So it will be, I think, somewhere here. Okay, so that will be that point there. So I can put a closed circle here. Why? Because here the interval has a closed circle, right? Okay, and then if it's minus 1, we're saying it's 2. So it can go like that. And then if it's 0, if my x is 0, you're getting 1 there. Okay, so you can see that this line will just be a straight line from here, going all the way, passing through this point and going like that, right? Okay, but since the piecewise function, we're going to limit that graph. This graph should only exist when x is less than or equal to minus 2 there. Okay, so I'm going to use a different color to draw the graph. So if I use red there, what do I have? I have a line there. Forgive my drawing, I know it's bad. So I have a line coming from there, going all the way from there and passing through here. If I just draw the whole line like that, right? But since it's a piecewise function, I won't draw the whole line like that. I'll just draw the part where x is equal to minus 2 or less, okay? So it means if I draw a line here like this, I'm going only to draw this graph here that is down here. Yay. Drawing of dark little guys. Okay, I'm only going to draw this line. I mean, this line like that. Okay, because this line, it will be the one that will satisfy this x being equal to minus 2 or less than it. Okay, so all this part that is above here, I'm going to rub it. Okay, so I just drew it so that you understand. So the only part of the graph that is required for that region will just be this guy here, ending there like that. Okay, make sure that this one here is closed. Okay, so we have drawn for this guy, and then let's draw for this guy here. Okay, let's draw for this guy here. So we can see that this guy starts from minus 2 all the way to positive 2, right? Okay, and you can see that this is a quadratic function. So for you to graph it, you have to find those turning points, whatever, okay? But I remember I taught you how to sketch this graph using transformations, right? Okay, so you can see that this is just a quadratic equation shifted down by 1 unit, okay? So if I draw a graph here like that, this will be the graph of what? This will be a graph of x squared. But this x squared has a minus 1, meaning it has been shifted down by 1 unit. So here where it was standing at 0, 0, it has come here, okay? So it means that graph now is coming like that, and then going like that. This will be the graph of x squared minus 1, okay? From the original here, it has just been shifted down by a minus 1 there, okay? So you can rub that first one. I only drew it to show you what was happening, okay? So it is as simple as that, but we know that this graph here should only exist from minus 2 to what? To 2, right? Okay, so it means it should just end here, like there, okay? But what circle are we going to put here? On the minus 2 there, we can see that it's just less than, right? So we're going to put an open circle there. And then here on the 2 here, if I go up here, on the 2 here, what am I going to put? I'm going to put the closed circle because here I have a closed circle, right? So I'm going to have a closed circle here. Means this part of the graph here should not exist, and that part of the graph should not exist, right? Okay. So I'm going to rub it now and draw it only in the region that it is needed. Okay. So let me use blue. Okay, so we know that that graph here on the middle is only needed from where this guy here with an open circle, then it comes down there, passes through this 0, minus 1, then it goes like that, then it ends here, closed circle. Okay, so you can see here it's a 2, then there's a -2. So that would be the graph of the second part. And then
Excuse me.
yes.
I'm kindly asking if you can just explain a bit on the closed and open circle.
On the closed and open circle.
Yes.
Okay, so here I'm saying that. Okay, here I'm saying that here, why are we putting an open circle here? Because on the -2 here, if I go in that region here, on the -2 here, you can see that x is just greater than -2, right? There's no that symbol equal to down there. No wonder we are putting an open circle there. And then on the other side, it is x is less than or equal to 2, meaning this 2 is also included. No wonder we are putting a closed circle there.
All right, thank you.
All right, okay. So we've drawn the first part of the graph, which is this guy, which was just 3x plus 1. And then we have also drawn the second part there, which was what? X squared minus 1. And then now we have to draw the third part there. I don't even know. Is it going to fit there? Okay. So the third part there, they're saying x minus 2x for the region starting from 2 here going all the way to infinity. Okay, so you have to plot this, you have to draw a table of values for this to know how it will behave. Yeah, so for a linear function, you always draw like a table of values. What's happening? Okay, so let's draw a table of values for it and see how it will behave. Okay, so this is our table of values here. So this is our x, and then this is my y, which is represented by 1 minus 2x, right? Okay, so what values am I going to put there? I can just put values that are greater or equal to this number. So I'll start from 2, 3, 4, and then I see the behavior. So if I put 2 there, what am I going to have? If I put 2 where the x is there, it will be 1 minus 2 multiplied by 2, which is minus 4. So 1 minus 4, this will just be what? Minus 3, right? Okay. And then if I put 3 there, it will be 2 multiplied by 3, which is minus 6. 1 minus 6, this will be minus 5. And then if I put 4 there, it will be 2 multiplied by 4, this will be minus 8, plus that one, this will just be minus 7. So we can see that going this side, if I put 2 there, it's giving me a 3 here. Okay, and then if I put 3, it's giving me a minus 5, which can be somewhere there. If it's giving, if I go to another 4, which can be somewhere there, it will give me something there. Okay, and then these guys will just make a straight line there, which should go all the way to the top like that. Okay, but it won't go to the top like that because it's limited that x should be greater than 2, right? Okay, so it means on this down part here should be our graph. This one on top, it won't be there. Okay, so I just drew it there to show you that it's not even needed. Okay, so what kind of circle are we going to put here? Okay, we can see that this guy here is just a greater than. It's not a greater than or equal to. So meaning here we are going to put a what? An open circle there and show that the graph is going like that. So let me zoom out. Okay, so that you see it properly. Okay, so you can see like a graph there, right? Okay, so this last graph here is for 1 minus 2x. So we had this graph here for 3x plus 1, okay? Then we had that graph, x squared minus 1, and then now we have this graph here for x minus 2x there. Okay, so that's how you graph that, and then we can move to the next question. Okay, what's the next question now? Okay, question 2, they're saying define. Okay, so you can see that the definitions are needed, right? So they're definitely, they're going to pop up. They're going to be there in your exam. 2 or 1 definitions, they're going to be there. So you just have to know some definitions. Even for the polynomials, they like doing those two definitions. Okay, so question 2, they're saying define subjective function, a singleton set, and an equivalent relation. Okay, so what are those? Okay, so anyone who can define what a subjective function is? Anyone who can try? What is a subjective function? Hello, no one knows. So if it came in the exam, you would have failed all of you. Okay. All right. Since no one knows. Okay. Okay, so before I define what a subjective function is, let me define this simple definition first. So what is a singleton set? Anyone? What is a singleton set?
A singleton set is a set with only one element.
Okay, yeah. Okay, so that's correct. So a singleton set is a set with only one element. That would be a singleton set. Okay, and then what is an equivalence relation? Okay, so an equivalence relation, the way you define it, you just say it's a relation that has to satisfy three properties. Okay, so an equivalent relation here is a relation. Okay, you will be finishing this way that satisfies three conditions. Okay, that satisfies three conditions there. So what are the conditions there? Is that one, that relation has to be reflexive. Okay, so that relation has to be reflexive. And then two, that relation has to be what? Okay, has to be symmetric. So if you forgot these things, you have to remember, right? And then three, that relation has to be transitive. Okay, it has to be transitive like that. Okay, so if you have a relation that satisfies the property of reflexivity, symmetric, and transitivity, then that relation is known as an equivalent relation. Okay, so what is reflexive here? Just simply means that every element of a set is related to itself. Okay, so if I have, let me have a set here, 1, 2, 3. So for me to have a reflexive relation there, it means I have to have 1, 1 in a set. I have to have 2, 2. Okay, and then I need to have 3, 3. Okay. Yeah. So if I have a set, okay, so this can be set X. Then from this set X, I'm getting this relation. So you can see that each and every element there is related to itself, right? Okay. So that's what reflexivity means. And then what does symmetric means? Symmetric means just simply means that if 1 is related to 2, then 2 should be related to 1. So if I have a set here where I have, what's happening? What was it drawing there? Okay, so meaning if I have a set there where I have 1, 2, then in this same set, I should have 2, 1. Okay, so this is symmetric. 1 is related to 2, 2 is related to 1. Okay, and then transitive, it means that if I have 1 related to 2, okay, and then 2 related to 3, okay, then it means that 1 is related to 3. You can see that, okay? So this is transitivity in simpler terms. If 1 is related to 2, and then this 2 is related to 3, it means even this 1 is related to that 3. Okay, so it should be like that. Okay, so if it satisfies these 3 properties, then it is an equivalent reaction. Okay, but in your test, no need to show what I was showing here, just trying to make you understand. Just say that an equivalent relation is a relation that satisfies 3 conditions, which is reflexive, symmetric, transitive. Then you'll be home and dry, right? Okay, but let's go back to the subjective one, the one we, yes?
So, sorry, if you can transitive.
On the transitive? Okay. So on the transitive, I was simply saying this. If I have 2 being related to, I mean 1 being related to 2, okay? And then this 2 is related to 3, okay? If this relation is transitive, it means this 1 will be related to that 3, okay? So 1, 3. Why is it that? Because this 1 is related to 2, and then this 2 is related to 3. It's like this 3 and 1, they're being connected by these 2 in between. You can see, right? Okay, so it means even them, they can be related as this 3, 1, 1. This is transitive. Okay, let me use the inequality symbol for you to understand it. Okay, so if I say 1 is greater than 2, right? And then I say, oh no, 1 is not greater than 2. Let me write this the other way. Okay, if I say 2 is greater than 3, why am I choosing smaller number? Yeah. So if I say 2 is greater than 1, right? Okay, then it means what? It means that, if I say 2 is greater than 1, and then I also say 1 is greater than 0, then it is also true to say that 2 is greater than 0, right? Is it true? So this is what we are doing here. You can see that the 2 is greater than 1, the 1 is greater than 0, meaning that this 2 is also greater than this 0. So this 2 and 0 have been related by these 2 1s in between. So it's the same here. This 1 and 3 have been related by these 2 2s in between there. So that's transitive. Is it okay now?
Okay.
Okay.
Yes, thank you.
Let's do the subjective one. Okay. Okay, so subjective, you can define it in many ways anyway, but a subjective function is simply a function where the element, okay, where the element in the second set, okay, or in the output set of the function how should I say it? A subjective function is a function where each element in the second set is the output of the function when an element from the first set is used as an input function. Okay, so let's say I have a set there where I have 1, 2, and 3. Then in between here, I have a function f of x. Okay, and then this is mapping to, let me say 2, 4, and 6. Okay. All right. So a subjective function states that, okay, every element of this guy here, okay, is as a result of applying an input element from the sets from the first set into this function here. Okay. So from 1 to 2, from this 1 to 2, what can be this function that we are using there? Okay, this f of x can simply be equals to 2x. Okay, so this can be equals to 2x like that. So that when I take 1 as an input there, you can say I'm getting 2. If I get 2 as an input, I'm getting 4. If I get 3 as an input, I'm getting 6. Okay, so that's what subjective function is. Okay, every element of the second set is as a result of applying an input function from the first set in this function. Okay, so let's say, for example, in this set, maybe I had an extra element here. Maybe I say 7. Okay, so you can see that this one won't be a subjective function. Okay, because not all of these elements here will be obtained by inputting the elements of this into this function. Okay, you can see that none of these inputs will give us a 7 there. So this will not be a subjective function. Okay, so let me define it again. Subjective function is simply a function, okay, where each element of the output set is as a result of inputting an element in the first set into a function. Okay, that's a subjective function. Okay, so these definitions, try to go through the notes and what you'll find. Okay, let's go to questions now. So B, they're saying determine the domain and the range of this function here. Okay, so the domain of this function here is equals to, we have the root of 2x plus 3, and then we are dividing this by what? By 5x minus 3. Okay, so how determine the range and the domain of this? Okay, so we can see that this one is a rational function, but in that rational function, we also have a radical function, right? Okay, so a radical function as a result of that square root in the numerator. And then it's a rational function because it's a fraction. A certain function is being divided by a certain fraction, right? Okay, so how do we find the domain and the range there? Okay, so the domain, we know that for a rational function, the denominator there should never be 0, right? Okay, so we are going to say 5x minus 3 should never be what? 0. And then we solve for x. So if we solve for x here, okay, you can see that 5x will not be equals to what? To 3. And then the x should never be equals to what? To 3 over 5. Okay, so this is the first condition for the radical function, rational function there. This guy should never be 0. So meaning we can use any value here apart from the 3 over 5, right? Okay, so the domain will just be a set of all real numbers apart from this guy. But we are not done because this function here is a combination of 2 functions, okay? So we also have to find the domain of that radical function there. So for a radical function, we said, how do we find the domain? We just get whatever is under the root there. Then we say should be greater than or equal to 0, okay? Because we can't find the square root of a negative numbers. So meaning whatever is there should be greater than or equal to 0, right? And then we solve for 2, for x, I mean. So 2x will be greater than or equal to minus 3. Then we know that the x just be greater than, okay, or equal to minus 3 over 2. Okay, and then once we get this, okay, once we get this, we can simply put it as 1 now, okay? You can put it as 1. So what can you say? Okay, what can you say? You can say that my domain is, okay, maybe I try to put it on a number line so that people can understand. Okay. Okay, let me try to put it on a number line before I write the final domain. So if this is my number and I have 0 there, this minus 2 over 3 can be somewhere there. And then that's 3 over 5 can be somewhere there, right? Okay, so we are saying the domain can be any number apart from this number. So we're just going to draw an open circle there and say, here we are getting any value, even this side we are getting any value. Okay, and then from this guy here, we can see that we are only getting values that are greater than or equal to this number. So meaning we are starting from here. Then we are going greater than. Okay, these are the values that we are taking. So where does this guy here, the first line there that I've drawn, intersect with that line? We can see that it's this region here. Let me get it in red. We can see that it's this region here, okay, all the way up to this value, but jumping it, then going like that again. Okay, so we can have two regions for the domain there. So we say the domain is equals to, okay, starting from this value, which is -3/2, okay, all the way to this value, which is 3/5, not including it, because we are not including, there's an open circle there, guys, okay? But this value here, we are including it, and then we are saying union, okay? Starting from this same value, not including it, then all the way up to what? Positive infinity. Okay, so this here is our domain, okay? This is our domain there. That's how we can show it on the number line there. Okay, and then they're saying find the range of this, okay? Find the range of this. So how do you find the range of this? Okay, how do you find the range of that? Okay, so whenever the okay, let me write it again here. So if I have f of x is equals to the root of, okay, what did we have there? We're at 2x plus 3 there. And then in the denominator, we had 5x minus 3, right? -3 there. Okay, so whenever we said whenever we are finding the vertical asymptotes, okay, whenever we're finding not the vertical asymptote, I mean the horizontal asymptote, okay, if the power of x in the numerator is less than the power of x in the denominator, then our horizontal asymptote will always be 0. That's what we said, okay? Because this guy here on top is the same as writing this. The same as writing 2x plus 3 to the power half, okay? Okay, so if we expand this using binomial theorem, which you don't know, I know you don't know it, okay? The power on x here will just be half, and then the power in the denominator of x here will be 1, right? Okay, so whenever you have the power of x in the numerator less than the power of x in the denominator, it means your horizontal asymptote is just 0, okay? So it means the range is just every number apart from 0 there, okay? So we're going to say range is, y is a member of all real numbers, okay? But this y should never be equals to 0. Okay, so that will be your range there. So this will be your range. And then whatever we found here was our domain. Okay, and then let's now, they're saying, hence sketch the graph. Okay, so sketching the graph is not hard, as long as you have the horizontal asymptote, and then this x value here, the one we said x should never be equals to 3/5 is our vertical asymptote, okay? So we are going to say, to graph this, we need the vertical asymptote, which is just what? X is equals to 3/5. And then our horizontal asymptote is what we are from finding just now. We said y is equals to 0. Okay, and then we can graph. So this will be equals to like that, 0. And then on the 3/5 there, you put your vertical asymptote like that. So this will be the line x is equals to 3/5 as our vertical asymptote. Then our horizontal asymptote is 0. So you just put a dotted line above the x-axis like that to show that the y there is equals to 0. So this is our horizontal asymptote, vertical asymptote. And then it means our graph will just be in this region here, going like that. Okay. And then the other one will be, will go like that. Okay, so this will be the graph here. So someone might ask, how do I know that is to draw the graph here and there and not there and there? Okay, so you can simply substitute 0 into your equation and see what y value is going to give you. If it gives you a negative y value, then it means this graph should touch this y-axis where there's a negative value there. Okay, so if you have one graph here, it means the other one is there. But if your y value there is, you find it to be a positive number, it means one graph will be there and then the other graph will be there like that. Okay, yeah, so that's how you graph that graph there. Okay, and then now what question is it? Okay, so the other question now, they're saying show that this is 1-to-1, hence find its inverse. Okay, so f of x is equals to 2x plus 1, 3x plus 2. Okay, so f of x is equals to 2x plus 1 over 3x plus 2. Okay, so how do you prove that a function is 1-to-1? You just have to find f of a and f of b, right? And then you equate them. You see if they are going to give you the condition a is equals to b. Okay, that's what we say. Okay, so if I find my f of a here, it just simply means that I have 2a plus 1 over 3a plus 2 is equals to, then I substitute b there, I'm going to have 2b plus 1. Then on the other side, what do I have? 3b plus 2 plus 2. Okay, so this is what we have. So this means what? It means whatever is on top there is equal to each other. Even what is down there is equal to each other. So our first equation will be 2a plus 1 is equals to 2b plus 1. And then our second one will be 3a plus 2 is equals to 3b plus 2. Then we try to establish the relationship that a is equals to b. So from here, you can see that I have a positive 1 and a positive 1 this side. So if one of these ones follows the other, it will just be 0. So it will be 2a is equals to 2b. Then you divide by 2 both sides, you're going to get a is equals to b. Okay, so here it's satisfied, that is 1-to-1. Let's check the other one. Even here, you can see that I have 2 there. If this 2 follows the other, it will just be 0. So meaning I have 3a is equals to what? 3b. And then this simply means that a is just equals to b. Okay, so even here it's satisfied. So since we have found that a is equals to b there, it means that f of x is what? Is 1-to-1. Is 1. Okay, to 1. Okay, then after finding that it's 1-to-1, now find its inverse. So finding its inverse, you're just going to replace the f of x with y. And then you say 2x plus 3 over, okay, that was plus 1 here. Okay, it's 2x plus 1 divided by, and then there I have 3x plus 2. So I'm just trying to make x the subject of the formula. So what do I do? Multiply by y. They are multiplied by 1. So it will be 2x plus 1 is equals to 3xy plus 2y. Okay, and then from there we get the x's together. So it means 2x, this 3x comes to the other side, so it will be minus 3xy is equals to, here you have 2y, then this 1 here goes to the other side, right? Okay, so minus 1. And then here we factorize the x. So x, and then what do we remain with? We remain with 2 minus 3y is equals to 2y minus 1. Okay, and then we divide both sides by this 2 minus 3y. It means our x will just be equals to what? 2y minus 1 over 2 minus 3y. Okay, so this is our inverse, and then we write it in the standard form. So it will be the inverse of f of x is equals to 2x minus 1 over 2 minus 3x. Okay, so this is our inverse there. Okay, we're done. We go to the other question. So we are on D now. We are on D now. Okay. So D, what does it say? Okay, they're saying let U be equals to 1, 2, 3, all the way up to 11. And then A, they're saying it's 2, 4, 7. B, it's 3, 5, 7, 9, 11. C, it's 7, 8, 9, 10, 11. So they're saying verify that the complement of the intersection of A and B is just equals to the complement of A union the complement of B. Okay, so here we're first going to find the A intersection B. Okay, so A intersection B, can list it here. So elements that are both in this set and that set, they are what? We can see that it's just 7, right? Okay, so this will be 7. And then, so it means that A intersection B complement will be equals to what? Okay, it will be equals to all the numbers that are in this universal set apart from 7. So A intersection B complement will just be 1, 2, 3, 4, 5, 6, 7. We jump it, so it will be 8, 9, 10, and then 11 there. Okay, so that will be our A intersection B. Then we prove that it's equals to A complement intersection B complement. So first we are going to find our A complement here. So A complement is all the elements that are not in A. So meaning 1, 3, 5, 6, 8, 9, 10, 11. Okay, so this will be our A complement, and then our B complement will be what? Okay, our B complement will be all the elements that are not in B, but they are in the universal set. So meaning 1, 2, 1, 2, 3. Okay, 3 is in B, so it's not there. So 4, 5 is in B. So we go to 6, 7 is in B. We go to 8, 9 is in B. We go to 10, 11 is in B. Okay, so this is what we have. And then let's find now A complement intersection B complement. Okay, meaning we're just getting elements in here and there, but without repeating any. So 1, 2, 3, 4. I can see 5 there. I can see 6. There's no 7, but I can see 8. I can see 9. Okay, this is 9. I can see 10 there. Okay. What is that? Yeah, so I can see 10 there and I can see 11. Okay, so now let's compare these two sets. This set here and these two sets. We can see that they are equal, right? Because all the elements that are here, you can also see them there. Okay, so hence proved. You can even write hence proved. Okay, but write it in an orderly manner, not the way I've done here. Just that I have limited space here. Okay, so we've proved this one, D. Then let's go to E, which I think is the last question here. Okay, so E, they're saying what? They're saying let A, comma B, let A, B, and C be the sets such that A union B is equals to A union C. And A intersection B is equals to A intersection C. Then they are saying that show that B is equals to C. Okay. So that's what we are going to do. Okay. So we need to show that B is equals to C. So how do you do that? Okay, how do you do that? Okay. Okay, just a minute. We solve our last question, then we'll go it a day. Okay, let's call him this time. Okay, sorry for that. Let's finish up. Okay, so we have these conditions here that I'm going to write. Okay, so they said if A union B is equals to A union C, okay, and A intersection B is equals to A intersection C, okay? They're saying if they give us these two conditions, show that B is equals to what? To C. So how are you going to show that your B is equals to C? Okay, how are you going to do that? Okay, so the simple method that you can do is you have to prove, okay? You have to prove that B is equals to this, and again, C is equals to, okay, in short, you have to prove that B and C, they are subsets of each other, then they become equal. Okay, so here what we are going to do is that we get this first equation that we've been given in terms of set. So we're going to say A union B is just simply equals to A union C. Okay, and then on both sides, we are going to intersect B. Okay, we are going to intersect B first, and then later on intersect C, and see if they will give us the same thing. Okay, so if on this set here and that set there, I intersect B on both sides, I'm going to have A union B in brackets, then I'm going to say intersection B is equals to, okay, A union C, and then intersection B. Okay, so from here, what do I want to achieve? I want to find, I want to make B like the subject of the formula, right? Okay, so what am I going to do to make B the subject of the formula? Okay, what am I going to do to make B the subject of the formula? Okay, so here I'm going to use the distributive laws to distribute this guy into this and this guy into that, okay? So if I distribute intersection B into this guy, I'm going to get what? I'm going to get A intersection B, okay? And then union, and then here, what am I going to get? B intersection B. I'm going to get B intersection B, and then is equals to, here again, let me distribute, okay? So A with the intersection B is going to give me A intersection, okay? And then union, the other one will be C intersection B, right? Okay, so now on both sides, okay, on both sides, we can see what? We can see that we have A intersection B, and then on the other side again, we can see that we have what? A intersection B, right? Okay, and then here we know that B intersection B is simply what? It's simply B, right? Okay, so if I can rewrite this again, it will be A intersection B, and then union B there. Okay, And then from there, what do I have? Okay. From there, what I have is that my B will just simply be equals to A intersection B, okay, and then union C intersection B, okay. So on the other side, I have this one, union C. Okay, so this is what I have on this side, right? Okay,